Hi, I'm Chris MacDonald and I'm really interested in industrial strategy. This video is part of a mini-series on the circular economy, and today I'm looking at critical materials. The world has a long history of conflict when it comes to valuable and scarce resources, be that the conquistadors' hunger for gold in South America or European powers seeking out control of the Spice Islands in Southeast Asia. For most of our modern history, the resource has been oil and the conflict has been in the Middle East. This is now changing. Access to rare earth materials is now vital for future technologies, and we can see the power play for resources such as cobalt and lithium as potential conflicts of the future. New technologies required to decarbonise our economy depend on a set of raw materials that are both critical and scarce. From platinum to palladium, niobium to neodymium, gallium to germanium, these elements are essential for fuel cells, photovoltaics and LEDs. The manufacturing industries of the future depend on these materials classed as critical by the British Geological Survey. The challenge is that few nations hold sufficient of these resources in sufficient quantities. Fundamental as they are to economic growth, access to these materials is important for UK sovereign capability in industry, defence and foreign policy too. Just as the discovery of Borrowdale graphite in the 16th century enabled the UK to dominate the global writing instrument industry for almost 300 years, so Chinese dominance of the global graphite supply in the 21st century, with 64% of production and 24% of reserves, threatens ambitions for so-called gigafactories in Europe. In fact, with 40% of global rare earth reserves, combined with a canny foreign policy initiative in the Belt and Road, China could dominate the green technologies of the future, such as smartphones, electric vehicles, and renewable energy. For the EU to achieve its target level of electrification by 2030 would deplete the known world reserves of lithium within 5 years and cobalt within 12 months. It's generally assumed that industry would find more reserves, but even a trebling would present a huge challenge. China already controls 80% of supply and is leading the world in the implementation of many green technologies at scale. The next challenge comes in upscaling these technologies. This requires new processes that either use fewer materials or increase efficiency. As this industrial revolution takes hold, we will see the increasing importance of materials and material science in both driving forward and capturing value from the supply chains of the future. The UK and governments around the world need to support industry in unleashing the forces of innovation to understand how these precious materials can be conserved, tracked, separated, reused and recycled. This can be an enabler for a circular economy with a cradle-to-cradle approach to manufacturing that is more environmentally sustainable, efficient and profitable. There are several more videos on my channel looking at other aspects of the circular economy, including gold, copper and lithium. If you would like to find out more about this or about industrial strategy and the social value of business, then do head along to my YouTube channel and click on subscribe. Bye for now.